Hello everyone. Today we're going to be practicing solving systems of linear equations presented in word problems. So a few things to keep in mind when solving questions of this type. Generally a good idea to define your variables first. You need to be able to create a system of two linear equations. You need to be able to solve the system, and generally a good idea to write a sentence to explain your results. So we've focused pretty extensively on sort of the last two steps in the previous classes, solving systems and to a lesser extent explaining our results once it's solved. We have several different methods at our disposal to solve a system of linear equations. The first we looked at was graphically. Generally the easiest. You can isolate your equations for y, put them in your graphing calculator, and find the intersection. So the intersection gives us this solution. We've also looked at a few algebraic methods to solve systems. First is substitution. Can you think of the next one? We did elimination. So hopefully you're pretty comfortable in these three methods that we've covered previously. The main focus of today is going to be getting a little more practice with these first two steps, which is often a bit tricky, but the more you practice with this, the more situations you encounter, the more comfortable you'll get, and it'll just be almost as automatic as solving with these three methods. So let's take a look at a few examples. So first, Sam invested a total of $15,000. He put part of it in a term deposit that paid 4% per annum, so that's per year, and the remainder in a treasury bill that paid 5% per annum, also per year. After 1 year, the total interest is $690, and we need to algebraically determine the amount that Sam invested at each rate. So the amount at each rate. So some of it was invested in the term deposit, and some of it was invested in the treasury bill. So we need to figure out each amount. We'll let X be the number of the amount of dollars in the term deposit, so I guess dollars in term deposit, and we'll let Y be the amount of money in the treasury bill. So we invested a total of $15,000, some of it in term deposit and some of it in a treasury bill. Suppose he invested the entire amount in the term deposit. Then we would just have X equals 15,000. We'd have nothing else to account for, right? Suppose he invested maybe $10,000 in the term deposit. Then how much would he have to invest in the treasury bill? So he'd have to make up the remainder. So it'd have to be 5,000, right? So when we add these two together, they need to come to $15,000. Next, we need to make an equation that gives us some interest information. So the term deposit pays 4%. If the entire amount was invested in the term deposit, he'd make 4% on $15,000. So 4% on $15,000 is 600. That's clearly not what it's telling us. It's 690. So some of it will need to be invested in the treasury bill. Now, if it was purely treasury bill, he'd make 5% of that amount. So if supposing it was total $15,000 all in treasury bill, 5% of $15,000 is $750. So that's a little bit more than is suggested in the question. So the actual answer will be kind of somewhere in the middle. So 5% on the treasury bill. So these two combine to make a total of $690. And now we have our system set up. So we defined our variables, we have our system of equations, and now we just need to solve the system. We need to do it algebraically. We can always fall back on graphically if we're looking to check or, but we need to do this algebraically. So given that, the coefficients are 1, it's pretty easy for me to isolate for either X or Y here. So let's maybe isolate for Y. And then we can maybe substitute, or we can even isolate both equations for y and then set them equal to each other. So anyways, this will be 15,000 minus x, and I can isolate this second equation also for y, so let's go ahead and do that. So 690, I'll subtract 0.04x from both sides, so 690 minus 0.04x, and divide by 0.05 to get y on its own. Okay, and now I have an expression for y here and y there, and I can set them equal to each other. So I just have one equation for one unknown, x, so I need to just solve this equation for x. I'm going to get rid of this 0.05 in the denominator there. To get rid of that, I multiply both sides of the equation by 0.05, so 0.05. 0.05 divided by itself on the right is just 1, and 0.05 times each of these things, make sure it hits both the 15,000 and the x. So that'll work out to be 750 minus 0.05x, and that's equal to 690 minus 0.04x. I now need to bring all the numbers to one side and bring all the letters to the other. Maybe I'll bring this over here, so add 690 to both sides. Subtract 690. Okay, that gets rid of 690 from the right side. 750 minus 690 is 60, minus 0.05x equals negative 0.04x. I need to bring this x over with the rest of it. Okay, so I add 0.05x to both sides, plus 0.05x. That works out to 0. 0.04 plus 0.05x turns out to be 0.01x. So we have 60 equals 0.01x. And I can finish this by dividing both sides by 0.01. 0.01, giving us finally x is equal to 6,000. And the rest needs to be made up by the amount in the treasury bill. So if 6,000 is in the term, that means 15,000 minus x. That gives us that y is 9,000. So I'm kind of running out of room. My sentence would be 6,000 was invested in a term deposit and 9,000 invested in the treasury bill. Let's have a look at another one. A store sells two types of lawn fertilizer. One type is 24% nitrogen, the other type is 12% nitrogen. Determine the amount that is needed from each type in order to obtain 10 kilograms of fertilizer that is 21% nitrogen. So if we collected 10 kilograms of fertilizer, and if it was entirely this type of fertilizer, we'd have too much nitrogen. And if 10 kilograms was purely this type of fertilizer, we'd have too little. So we need to come up with some combination of the two in order to get the required amount. So it might work out to be like 8 kilograms of this and 2 kilograms of that, or so determine the amount that is needed from each type. So the amount in mass. So we're looking for the mass needed from each type to obtain 10 kilograms. So X we'll call as the amount in kilograms of the 24% fertilizer, and we'll let Y be the amount, again in kilograms, of the 12% fertilizer. Good, we got our variables defined. We need to collect 10 kilograms, so this plus that need to add to 10. So they need to add to 10 kilograms. Next we need to make it so that it's a 21% nitrogen fertilizer. So 21% nitrogen in 10 kilograms of fertilizer. Suppose all 10 kilograms was of this X type. So X would be 10. If I had 24% nitrogen, that would mean I'd have 2.4 kilograms of nitrogen if all 10 kilograms was this type of fertilizer. If I used all 10 kilograms in the 12% fertilizer, I would have 1.2 kilograms. So to take a percentage, right, I do the percentage as a decimal, so 0.24x. Again, if it was 10 there, I would reach 2.4 kilograms. But we need some of the other type, which is 12%, so 12% of the other type. And I need to reach 2.1 kilograms of nitrogen, right? So 21% of 10 kilograms looks like that. So that would be 2.1 kilograms of nitrogen. That's the mass of nitrogen that we need to reach, so 2.1. Right, so that's our set of equations. They need to add to 10 kilograms. Percentage of one plus the percentage of the other. They need to combine to make 2.1 kilograms of nitrogen in the final collection. So it doesn't say that we need to solve this algebraically, so let's maybe go for the easiest way forward. We will graph this. So I need to isolate this equation for y. So y1 is going to be 10 minus x. And y2, so if I isolate this for y, I need to subtract 0.24x from both sides. I'll have 2.1 minus 0.24x, and I need to divide by 0.12, 0.12. So that is going to be y2. So I type y equals, right? I put this in for y1, and I put this in for y2. Probably a good idea to put brackets around the numerator here. So y2 I would write as like bracket 2.1 minus 0.24x, close bracket, divide 0.12. And then y1's pretty straightforward, 10 minus x. Good to go. The reason I put brackets around this is because if I don't, it might interpret me wanting to only divide the second term by 0.12. So I don't want that, so that's why I force it to divide the whole thing. Okay, you may have to mess around with the windows a little bit possibly. So you just hit window and you might need to adjust your x min or x max. So remember, x min is the furthest left your graph goes, x max is the furthest right it goes. By default, it's between -10 and +10, and y max and y min it also goes between -10 and 10. So you may have to adjust those. To find the intersect, you're going to go second and then calc function, so second trace. So scroll down to intersect, and you'll find, so it tells you to select graph 1, graph 2, so you just keep hitting enter, and then it tells you, prompts you to guess, and you'll find it's at 7.5 and 2.5. So we need 7.5 kilograms of the 24%, 7.5 kilograms of the 24%, and we need 2.5 kilograms of the 12%. And that gets us to a total of 10 kilograms at 21% nitrogen. All right, let's look at a couple more. Patrol boat travels 5 hours, 60 kilometers up a river against the current, and 3 hours for the return trip with the current. Find the speed of the boat in still water and the speed of the current. So it would be helpful to draw a little picture here. So we've got a boat. It goes, suppose the current is like this. So upstream, it's going a little slower because it's fighting the current. So it's got to go like that, and then it's got to return. So 60 kilometers is the full distance. We're going a little bit slower on the way up and a little bit faster on the way down because the current is working with us. We need to find the speed of the boat and the speed of the current. We'll let the speed of the boat be b, and we'll let c be the speed of the current. Alright, so for example, like if the speed of the current was, I don't know, 3 meters per second this way, like so downstream, and the boat was able to go, so let's say the boat is 10 meters per second, or let's go kilometers per hour, e.g. b equals 10 kilometers per hour. If the current was, say, 3 kilometers per hour, this means that the boat is able to do 7 kilometers per hour upstream, right? So it's 10 minus 3. It's relative motion. And on the way down, they add, so they'd be going 13 kilometers per hour when they go downstream. So it takes them a little less time to go down. We're working with speed, time, and distance. So the way they are related is speed is equal to distance over time. Right, so kilometers per hour, this is kilometers per hour. Alright, so 60 kilometers, 5 hours. So upstream, 60 kilometers, we have the distance, we have the time, 5 hours. We need to figure out the speed. So the speed when they're going upstream is going to be b minus c. B minus c. So in this example, it's 7, right? So 7, and then, I mean, that's not necessarily the answer, but that's the type of sort of calculation that we'll have to do. And on the way downstream, right, we have the same distance, so 60 kilometers again. This time it's only 3 hours. And this time the current is adding to the speed of the boat, so b plus c. So in our simpler example here, they're going 13 kilometers per hour on the return trip. Alright, so this is basically our system of equations. We have this, and we have this, and that's all we do. So maybe we'll just get rid of the denominator here. So we have 5 times b minus c equals 60. So that's our first equation. And we have 3 times b minus c equals 60 as well. Now, we can solve this by elimination. Sorry, this should be b plus c. We can solve this by elimination because the signs of c are opposite. And if we only just multiply each of these by, so if I multiply this entire equation by 5 and this entire equation by 3, you'll see that we can eliminate this fairly quickly. So multiply this whole thing by 5. So that would be 15, right? 3 times 5, 15. And then this 15 needs to distribute into the b and the c. So 15b minus 15c. And then 3 by 60 is 180. And then 5 by 3 is again 15, so it'll be 15b plus 15c equals, okay, 5 times 60 is 300. And now I just need to add, so I'll add this entire equation to this one. 15 plus 15b is 30b. Negative 15c plus 15c is just 0, and 180 plus 300 is 480. So we just need to solve that for b, divide both sides by 30, and that gives us the b is 16, so 16 kilometers per hour. And now we just need to figure out what the current speed is. So I can substitute 16 into any of these equations up here, and just solve for c. So substitute that in there. So it'll be 5 times 16 minus c equals 60. Divide both sides of this equation by 5. Divide by 5. Divide by 5. That's just 1. 60 divided by 5 is 12. So we get 16 minus c equals 12. I can subtract 16 from both sides. So subtract 16 gives me negative c equals negative 4. So therefore c is equal to 4 kilometers per hour. So if you got space, you can write like a short little explanation there. The speed of the boat on its own is 16 kilometers per hour, and the speed of the current is 4 kilometers per hour. A truck leaves the city, travels at 95 kilometers per hour. 1 hour later, a car leaves the city and travels the same highway at 120 kilometers per hour. Determine the distance the vehicles have traveled when they meet on the highway and how long each vehicle has been traveling. Same kind of thing. Speed is distance over time, so speed is equal to distance over time. Kind of helpful to think of this graphically. So if we graph time and distance, if we were to graph the truck, I think the truck's like that, the slope gives us the speed, so 95 kilometers per hour. If the car started out at the same time with its speed of 120 kilometers per hour, it would be, well, maybe that's a bit extreme, but it would be steeper. So the trick with this question is to adjust this car so that it is starting later. So we want it to start here at 1 hour. So we need to sort of move this forward, and our solution, right, will be where they cross. So determine the distance the vehicles have traveled when they meet on the highway and how long each vehicle has been traveling. So we'll get a certain time here, maybe could be like 2 hours, for example, e.g. like 2 hours and 300 kilometers, for example. I don't know that that's the solution exactly, but that's kind of the idea. So the slope of this line needs to be 95, and the slope of this one needs to be 120. And all we need to do is find the intersection point. The equation for the truck is fairly intuitive, hopefully. So I guess we'll let like y, so instead of d, we'll use y. Instead of t, we'll use x. So y equals 95x. That's for the truck. X is the time, and y is the distance. Just a bit sort of disorienting when you're using x for t and y for d. But we're just trying to accommodate the limitations of our graphing calculator, so we need to use y and x. Alright, so now we need to figure out sort of the y-intercept of the car, right? Situation here. So I have the graph of the truck here, right? 95x, and here I just have it restricted so that it is as a positive distance. And I also have an equation, possible equation for the car. The slope of the car needs to be 120, and this minus a just gives me a horizontal translation. Again, I'm restricting it so that it is a positive distance. So I'll turn that one on, and simply, right, if I let this value be 0, it's just 120 times x, right? But if I bump this value of a up, you can see that the start, where the car starts, is being pushed further along in time. So I mean, here it starts like 30 minutes later, and then it starts an hour later here, and an hour and a half later. We want it to be 1 hour later. All right, so if I sort of remove this range restriction, you can see that it crosses at minus 120. So if you wanted to write this equation as a slope y-intercept form, it would be 120 times x minus 120. Will be 120 times x minus 1. So that's for the car. We need their distances to meet. So, I mean, graphically, pretty simple, especially on Desmos. We just find where they intersect, and I can see, so that's at 4.8 hours. They've each traveled 456 kilometers, and this point is where the car overtakes the truck. So it starts 1 hour later, it catches up. This point, the car passes the truck, and it's leaving the truck in its rearview mirror beyond here. We can solve this pretty simply with substitution. So I have in a system of equations, this is y, this is also y. The y values correspond when this equals that, so I can go 95x equals 120 times x minus 1. Okay, so just solve for x. So 120 distributes, if you like, there. So we have 95x equals 120x minus 120. I'll maybe bring all the x's to the right side. So I'll subtract 95x from both sides. So I have 0 equals 25x minus 120. I'll add 120 to both sides, giving me that. And finally, divide both sides by 25. 120 divided by 25 is 4.8. So x is 4.8. And that would be hours. So that's the time when the car and the truck are sort of neck and neck. And we also just need to figure out the distance they've traveled. So now that I have x, I can just sub that in. So I can sub that in here. It's probably the simplest. I could sub it in here and solve for y as well. But just multiplying by 95, that's pretty simple. So y equals 95 times 4.8. Y is equal to 456, and that would be kilometers. So at 4.8 hours, the car and the truck have traveled 456 kilometers, and that is the point that they meet. All right, so that's it for me for today. Please try some of the practice questions for today, and I'll see you next time.